data modeling in Python, and I'm gonna show you how to demonstrate data modeling in Python practically. First of all, let's describe what is data modeling in Python. What is data modeling? Modeling is the process of analyzing the data objects and their relationship to the other objects. It means that the data models are just created for data to be stored in the database. The first thing to analyze the data objects is we collect data and organize data. Then we analyze the data objects of our data. And we also analyze their relationship to the other objects. So the data models are basically used to analyze the data requirements that are required for the business processes. If we have a business or we plan to open a new business, first of all, we should have to collect, organize our data, and analyze the data objects and their relationship to the other objects. That are the basic requirements for our businesses. So data modeling is the best thing to analyze our business models. The data models are created for the data to be stored in the database. So our target is analyze our data and to then create model for that data to be stored in the database, and we then retrieve the data for any purposes. The data models mainly focus on what data is needed and how we have to organize our data, that rather than focusing what operations we have to perform in our data modeling. But we need to focus on what data is needed and how we have to organize our data for our business processes. That is the main focuses of data modeling. Basically, data model is an architect's building plans, like building a house plan, like a house plan. Before building our house, we have to plan the architectural blueprints of our house. Like building a house, we have to put the architectural plans of data models. Then we can build our model. The practical uses of data model tools are, it helps us to create a robust design. So what data modeling, generally, data modeling is the process to formulate data in an information system in a structured formats. That is creates a robust design. The data models makes sure that the data models are represented correctly. The database at the logical level, physical level, and the conceptual levels can be designed. The relationship or the relation tables, foreign case, primary case can be defined, and the relationship it also help in the improvement of data quality. So the main things of data modeling is that it help us to improve the quality of our data for our business processes. It gives clear pictures of business requirements and data models that can help us to identify redundant and missing data. So this is the best and practical uses of data modeling tools. We create visual representations for our data, and it is quite time consuming, but maintenance is cheaper and faster if it is to model our data. Because first of all, we should collect our data, organize, and model our data. Before modeling our data, the data should be needed, and what and how we have to organize that data. That is a time consuming, but maintenance is very, very cheap and faster than the other models. data can be accurately represented in data modeling. So that's at the basic practical use of data modeling tools while analyzing your business processes. These are the practical uses of data modeling tools. And data modeling, while modeling our data, there are three perspectives of data modeling. The first one, conceptual models. Just think about the models conceptually, what the system contains. Just think about what the system contains. Actually, in the data modeling helps us to create a conceptual model and create the relationship between objects and the other objects, between the items. And the basic data modeling techniques involve dealing with three perspective data modeling concepts are the conceptual models, that what the system content. So this conceptual models is the view of the data that is required to help us our business processes. It also keeps track of business events and related performance measures. So the main purpose of this conceptual model is to organize, define business rules and concepts. For example, market data. First, we collect our market data and organize our market data, customer data, purchase data, etc. So this is the conceptual models of data modeling. The other, once we have to model our data conceptually, or which means we organize, collect, organize our data, define business rules and concepts about our data, our model, then we transform to the logical models. The logical models of data modeling is that the map of rules. We have defined the rules in the conceptual models, then we map the rules and data structures, increase the data required, such as tables, columns, etc., used to transform data architecture into a database. That is the logical models generally. Just we define the rules and concepts and organize our data in the conceptual models, then we transform into the logical model. The logical model is just map rules we defined in the conceptual models, and also data structures included the data required for our business processes, such as tables, columns, etc., used to transform data architecture or blueprints into a database. So this is the most important model. The second perspective of data modeling. The third perspective of data modeling is physical data models. Just we put the physical structures of our data model, define all the components and services that are required to build a database. It represents each table, columns, constraints like primary key, foreign key, not null, etc. So this physical data model is the third perspective for data modeling. It is very important. The first, we conceptually define our data model, the rules and other concepts. Then we map rules and data structures that are included in the data required, such as tables, columns, etc., and transform the blueprints of our data models into database. Once we transform into a database, we physically define all the components and therefore services that are required to build a database. Like it represents the physical models represented like each tables of our data, columns, constraints like primary key, foreign key, not null, unique, null, etc. So those are the three concepts of data modeling, the three perspectives of a data model. So we go through these three perspectives to model our data, The other most important things are techniques used to organize our data in the data. The first is hierarchical techniques. It is like a tree-like structures. Actually, we don't use all structures techniques at the same time, but we choose one from the this perspective. There are five perspectives, techniques used to organize our data, but we can choose one of the five techniques to organize our data. Which one is best? You can choose one. It is a tree-like structured hierarchical technique. Object-oriented model is actually the well-known, especially if you are working on Python. This one is best to model your data, object-oriented model. I prefer creation of objects that contains stored values. The model communicates while supporting data abstraction, inheritance, encapsulation, polymorphism, etc. The third one is entity relationship models. Actually, this is not object-oriented, it is structural. Defines the elements relationship for the entities in a system. The entire database is represented in a diagram called an entity relationship diagram, consisting of entities, attributes, and relationships, like object-oriented. Network technique and relational techniques, that are the other techniques. But today I'm going to show you how can we model our data in Python using object-oriented techniques, object-oriented techniques. Now let's develop a data model of for PISA. Let's model data for PISA. Create data model for PISA. The first thing is just create the model that is the class for PISA. That is class PISA. This is then all the attributes. This is the object. I mean the class, the model of our PISA, the class name of the PISA, and we have to define all the attributes, the elements in this class. Like this is our data model, and we call that the object of it, and the attributes like number of slices, how many number of slices you wanted to buy, like just a string. Actually, real code might be a enum, but you can just, actually it is the size of, no, it is a slice number, int. And the size, like medium size, large size. Actually, I know PISA in mediums, large, and small size, 3 sizes in PISA. Actually, I like vegetable pizza. Not I am vegetarian, and I like vegetable pizza. And I always, I usually eat medium size with my friend, my wife, or other friends who invited me to eat pizza. Okay, size is the matter. It probably it is type of the data is integer string, and the other is price in USD or in other in your local. The other is price. That is probably not integer, or it is float, yeah, because it may be in it may be in centers or blah blah. Then once we you can define more attributes, more properties for our PISA data, PISA class. Actually, this is enough for demonstration for today's lesson. Okay, then we define the number of the method for each defined method like set number of slices. This is the method. Actually, we create this class like a Python class. I'll copy it and the Python, and it doesn't matter, no problem, and we can import as a module. Then we set here serve slice number of slice, and we object called self, that is the pizza object self by itself. When you instantiate this object, automatically the object name is assigned to the self keyword, and automatically we call this self keyword and assign to the attributes the number of slices, and that is number of slice. And we also define another class that is the size that sets, or I mean, getter and setter class. We get the number of slices. Here, just return the slice. The object is important here, and we just return. Getter and setter method is important in data modeling. We set the values for our data, and we get that setted value or stored value from the database. Serve dot number of slice. And the third method is we define the method for set the size self size, and serve dot size is size. Actually, this underscore represented that we define our variable in private mode. This is if we define the variable is private, we use underscore before the variable name. That is to keep our variable private. It could not be accessed outside this class that is private, because private variables will not access outside of that model class. If variables are public, it can be accessed everywhere in the class or outside the class probably. This is just keeping the variable private, and we define the get size method and return the size of the pizza. Return self size. And the third method we have left is price. We define set price, and then we have to assign self price to price, and the final class we have left is get price. We get price we have inputted in the method in the class model, and we just return this method value serve price. Now we have finished our model. We have finished. Let's save this in the Python, because I'm working on Jupyter Notebook, and the file the file path is different. The file is different, not a Python file. I just create here. I create a model here, and I can paste here. This is a data model in the model class, and the data.py, which contains a model for pizza, and all the setter and methods are correctly defined here in the class. We can just import here from data. We import, data.pizza. We import, model.data import pizza class. This is because I have defined the models in the data.py file, and okay, here in the model there is error. That is here I missed comma, because self and the variable arguments should be separated by the comma, and now it's okay. And let's call all the method, the setter method, and we can set, for example, size pizza dot set size like large, right? Because the size it is a string, and number of slice pizza dot set number of slice slices, and for example 3 slice, and we also set pizza dot set price for our model, and we assert, for example, 100 USD. It's say 100 USD. That is once we define, we set or the set size missing one position argument. Oh, here I need to define the object pizza, then pizza like this. Then we define, first we define the object pizza, the object name pizza. That's why it's generates an error. It's okay. Now we get, for example, the size. We want to get the size. Pizza dot gets size large. You see the price, the size large, it automatically assigned to here in the module class. Then we get that using the getter method, that it gets size, get size, and it returns the size of the pizza. And we want to get number of slices It's print 3 because I have set 3 for the number of slices, and it automatically assigned to the set the number of slices, and pizza dot get price, it would be 100. We can set more pizza, for example, set size medium and pizza dot get size. Its size sets size medium, and it returns medium. This is the basic concepts of data modeling in Python using object-oriented concepts. So you can, so this is the way. We can also use database, we can store this data into the different database like MySQL, SQL, Postgre, or Oracle, whatever we want, and we can store a number of data, and we can retrieve the number of data using these data modeling concepts. The implementation of data modeling in Python in general. Next, we will see, in the next time, we will see how can we model using cloud. How can we demonstrate model using cloud database like Google App Engine. So for today, thanks for watching.